Welcome to another fantastic episode of the California Native Plant Certified Landscaper Program, brought to you by Theodore Payne and the California Native Plant Society and the U.S. Green Building Council and LADWP. And we are at 6:01. And Brenda, since this is your last time you'll be with us, I will allow you to do the land acknowledgement.
Oh, I was going to pick somebody else to do it. I do it all the time.
Oh, you can do that. That's fine.
Who the first person? George, are you comfortable giving a land acknowledgement?
You're welcome to unmute yourselves, obviously, for this.
George, okay, no George. What about Stephen? No, so who came in after Stephen? I mean, who came in after George? Robert, are you comfortable giving a land acknowledgement? George sent a message, he's eating dinner.
What does that mean? Huh?
So no volunteers to give a land acknowledgement? No? Okay. Then
Jack, I saw your hand.
Well, then Jack can do it.
Go, Jack.
I'll do my best. Thank you to the Tongva people whose ancestral land we are learning on and whose plants we're learning about and to work with. And thank you for being so graceful with sharing their knowledge.
That was beautifully said.
Thank you so much. Good job.
And again, if any of you haven't looked and are curious as to whose ancestral lands you're living on, native-land.ca is a really good website and resource. Thank you to everybody saying hello in the chat. We appreciate it. Jack is getting some love in the chat. All right, yes. All right, great. Well, we're going to begin today. So welcome. You're in module number 6, lesson number 6, and we're going to be talking all about soils. And yes, George, if we're cohort number 6, Brenda, I'm assuming there were 5 other cohorts before us. Is that correct?
Technically 12 because we had an English and a Spanish. So yes.
Yeah, so English and Spanish. This would be the English cohort 6. So yes, this is a constantly evolving and refining class and so, or, certification program. So we're thrilled to have you guys with us. As we're doing the last minute, are we the last cohort? No, we will never be the last. We will do this forever. And so, okay, so let's begin. And I want to make sure everyone can see my screen advancing. Hey, we're now on the second slide. We're going to do a little bit of homework review. You guys sent some really great homework assignments to me, as well as some of the in-class exercises that we didn't get to do last time. I want to apologize that we ran all the way to the end and didn't really get to do the in-class exercises, and that caused a little bit of confusion as to what was an exercise just for us to practice and what was the actual homework assignment. So for those of you who were super ambitious and sent me both things in emails, thank you so much, because we get to talk a little bit about all of it. The in-class exercises were really to familiarize yourself with the handouts, not the handouts, actually your notebook, but also the resources from your student handbook, the CalScape resource and all those other resources where you can check different plant facts and kind of conditions and information about each species, as well as your handy dandy set of flashcards. So that was more for you guys to familiarize yourself and get practice. The homework was to actually observe a native plant, a mature native plant, and compare it with those kinds of resources. So compare it to the information that you're seeing on the flashcard. Is the information about size on the flashcard consistent with what you're seeing? Is the information on Cowscape consistent across? Or are there natural inconsistencies, which is going to be the case with any plant? And so I'm actually going to stop the share and pop up a different thing just so we can look at some of the homework that we did. So first, I was thrilled with those people who did send me information that wasn't related to the homework assignment, but was related to the in-class exercise of comparing and giving alternative native plants to conventional ornamentals. So I just wanted to highlight 3 of them because they were really excellent and stellar kind of alternatives. So pyracantha with this red-orange kind of berry and evergreen leaf. The suggestion was that you could use toyon in its place. So for aesthetics, it's very, very kind of compatible with the benefit that toyon doesn't have inch-long wicked thorns the way pyracantha does, and has a bigger leaf and is generally, I would say, a friendlier plant with higher wildlife value. So that was a really excellent suggestion. So I just wanted to highlight one of the students who suggested that one. Another one that was really great. Maybe we can do a full screen sort of. Agapanthus, and the recommendation for agapanthus, an native alternative would have been Penstemon spectabilis, which is showy penstemon. So you got both that feature of kind of the low green foliage with these spikes of purple flowers consistent between the 2 of them. So that was a really great suggestion. And the other one that I really liked a lot was Dudleya hassii instead of ice plant. So ice plant came over to be used for erosion control from South Africa, ended up becoming a really invasive species that ironically is really bad at erosion control because it has very shallow roots and is really heavy. And so it actually creates landslides and such. So unfortunately, it's covering our beaches and really has destroyed beach dune habitat in California. A really great alternative as far as aesthetics would be Dudleya hassii, which kind of creates these clumping, similar finger-like protrusions of succulent growth. And so you kind of have a good aesthetic, but you're using a native plant. It's really nice because also Dudleyas can thrive in those kind of partial shade environments, so they can even work as an understory species. So for the actual homework assignment, which was to observe a mature native plant and compare the information that you're seeing in front of you with information that you're getting from the various resources like Cowscape and such. This was one of the really stellar examples and a perfect example of what we call right plant, right place. So this was from one of the landscape crew from the San Manuel tribe. And so if you read here, it says, I planted this 3 years ago. We chose a location that has a constant flow of water near a natural spring. So this is a riparian species that naturally grows in exactly that environment. So to have picked that species and planted it exactly where it wants to be is a perfect example of a riparian species being put in a place that's going to be completely self-sustaining and self-managing. So you can see it also creeps by rhizomes, so the colony has gotten much bigger, and they use this consistently for basket weaving and fibers, and also for food as well. So this has beyond habitat value, it has cultural significance as well. So I really, really loved this example and wanted to share that as kind of the first one. So this is another homework assignment. So what you're seeing is Salvia clevelandii or Clevelandi. And so it's giving you a comparison. This is, on the flashcard, it says, it'll go 5 feet. On Cowscape, it'll says it can get 8 feet wide, which is true in my experience. So this is the kind of thought-provoking, kind of deeper dive into the information that we wanted to kind of provoke with this homework assignment, was to get you to start comparing and contrasting the different resources on there. And then another example, somebody's toyon, a 9-year-old toyon, really beautiful. This is like mostly, full size. It can certainly get bigger with age, but this is kind of like a good mature size example. CalScape information as well, and then information about whether it's flowering, what kind of maintenance. So those were all questions as far as what was being asked. So you guys did a really, really great job. I really appreciate everybody who's sending things in. If I haven't gotten back to you, I try to respond to each of your emails, but some of you send it right before the class, so I'm not able to get there, but I'm looking at every single one, and so I really, really appreciate all your hard work. All right. Oh, see, I think this is going to give me trouble again. No, it's not. Okay, we're good. So here we have homework review, which we just did. So we're going to skip forward. All right, so now onto the lesson. Lesson number 3 is about soils. The objectives is to understand soil as being vital to the successful maintenance and of a garden and to customer satisfaction as well. We want you to be able to identify different kinds of soil textures and the relationship of those textures to infiltration rates. Infiltration just meaning how quickly or easily the water percolates into the soil, gets absorbed by the soil, and has water be able to move through the soil. Identifying soil-based problems faced by certain native plants is another goal, as well as describing the proper soil management through use of mulch and amendments or not using amendments. So the 4 components of soil are, I don't like just reading PowerPoints, but I'm going to read because it's a very simple PowerPoint. Minerals from broken down rock. So that's like the main kind of component. So mineral matter. Living and decaying organic matter. So usually when you see like gardeny, rich, dark, black soil, that has higher levels of organic matter compared to mineral matter. But when we're talking about native plant horticulture, and especially if you're doing any kind of like restoration work or anything where the soils are more less manipulated, you're going to have a higher mineral content and less organic matter. Living and decaying organic matter. Okay, air is the next thing that's a component of soil. So believe it or not, roots do need air. It's not just water and soil, and then water itself. So solids, you can see that little thing that just said solids came up on the left, pore space on the right. So pore space is represented by water and air. And the ability of water and air to move through the soil is dependent on how much pore space there is. So they provide 3 basic functions for plant growth. They anchor plants. They literally are the median through into which roots are anchored, which allow the top growth to exist on land and not just float in space or just get carried away by a wind, which still unfortunately happens a little bit. If you are familiar at all with California Botanic Garden, they lost lots of really, really big trees in the winds. That's not to say that there was anything wrong with their soil. Sometimes things like that just happen. But that's the basic function of soil and roots, and that relationship is to anchor them in place. It allows for microbial and fungal activity to take place. So it's, again, just like a breeding ground for kind of a microbiome underground. And then it facilitates moisture and nutrient movement, which is kind of going to be the major focus of this this course, because it's the most applicable to actual just horticulture and gardening. So soil texture is based on the proportion of sand, silt, and clay in the whole soil. So sand, silt, and clay are kind of the 3 main components of soil, and depending on how much or how little you have of each of those things, it classifies the soil as a particular type of texture. And so that's the mineral matter portion of what we're talking about. It's not the air. You know, sand is not air, sand is not water, sand is not organic. And so we are talking about the mineral matter and what that is composed of. That's going to be kind of your biggest factor in the soil and the most influential in how your plants are growing. So sand alone doesn't hold minerals well. It's very open, very permeable, and there's a lot of pore space and empty spaces. If you think about going to the beach, the wave comes crashing down, it passes, anytime water is sitting on it, it sinks in really, really quickly. So you're rarely seeing just, you know, pools of water that's just stagnating there. The sand is something that's very, very permeable. Because it's really permeable, it's also permeable to roots and root activity. And so in sandy soils, roots are really able to go through all the little voids and pockets and pore spaces and kind of create a really robust network of roots. They're not finding much resistance as far as physically being able to pass through the medium. Silt is kind of a sedimentary material. It gets carried off by water runoff or flooding. You'll often see it in those kinds of environments where if you were to touch it, it would be very silky to touch. And it's a much finer particle than sand. They're round, they're kind of smooth, it's silky to the touch, and the particle size is much smaller. And clay is even smaller than silt, but also has a different composition in that it's a flat particle. It's not round. So you have sand, which is kind of irregularly shaped. If you look under a microscope, a sand particle is not a perfect round ball. It's kind of this like a miniature boulder or rock. You have silt with it, which is much more smooth and round, but significantly smaller. And now you have clay, which is actually a flat particle. So these are kind of like flat, even smaller sheets almost that pile on top of each other. And they fit together very, very densely. And when they dry, you can see on the left, when they dry, they kind of break up in this kind of a way. They kind of peel back and you see a lot of cracks. So to give you kind of a size comparison, again, this does not mean the particles are perfect spheres, but this just gives you one of those size comparisons, very similar to if you see those size comparisons of like the Earth compared to Saturn, compared to the sun, compared to some other enormous sun in some other galaxy or what have you. So this is kind of on a micro scale, the size differences between sand, silt, and clay. So sand can then be anywhere from 2 to 0.05 millimeters, which is kind of a big range, but that's the range. Silt, 0.05 to 0.002 millimeters, and clay is less than 0.002 millimeters. So this is kind of a fun little soil texture triangle that can kind of help you identify, at least in a word or in a phrase, what kind of soil texture you have. This could be useful in conjunction with one of those jar soil separating tests. So you could fill a jar about 3/4 of the way high and fill it with like a teaspoon of dish soap, and then throw kind of a handful of soil in there and shake it up. And over time, the different material will settle into kind of 3 ranges, or maybe even just one. You'll see the heaviest material being maybe the sand on the bottom, then more silt, and then the clay might just make it foggy. But if it has really clear water and just a lot of material on the bottom, you have high sand and very little clay. But you might be able to do a little bit more of a realistic, like 50% sand, 40% clay, and 10% silt, kind of a comparison. And so this triangle will help you kind of identify what kind of soil you have. And so you use it just like a little kind of graph. So let's say you had 30% clay. So if you see my cursor is kind of hovering around the 30% clay, and sand is on the bottom. Say it was 30% clay and 60% sand. So you'd go across here. And what is 60? I passed it. 60 is down this line. So you just follow the line. So there's 60 and 30. So if it's 60, 30, then of course, yeah, you kind of just have to stop there. And then it would be 10%. Where's my little guy? Okay, 60, 30, and then it would be up here, only 10% silt. So you have to just do a little bit of math to get 100%. And so what you're finding, that's a sandy clay loam. Sandy clay loam is mostly sandy and pretty loamy and with a little bit of clay. Like sandy clay loam is kind of a nice combo. Loam is where you have all the sweet spot kind of hitting the middle. So most people say they want loam soil. It generally has pretty good drainage, but also has some nutrient capacity. So if you have really good drainage, you have, you know, sometimes some issues with not being able to hold moisture and nutrition long enough. If you have too much and you're in this whole clay zone, then you tend to have too much of a water holding capacity, and you can run into some other problems in the soil. And so you can see that once you reach 60% clay, or actually really 55% clay, it doesn't really matter how much of the other stuff you have, your soil is identified as clay. So anything really more than 50% clay is a clay soil. Obviously, if it's 100% clay, you're going to treat it slightly differently than if it's 60% clay, but that's going to be your designation, as this is a clay soil that I'm dealing with. So it's a very dominant feature, and that's one thing we want to kind of emphasize, that, you know, even 60% sand is not just sand, it's sandy loam, or 60% silt is like a silty clay or silty clay loam, but 60% clay dominates the whole thing. And so it's a very, it can be a challenging aspect to soil, and so we'll get a little bit more into that. But it also has some pros as well as its cons. So this says that it's an in-class exercise. However, I'm very aware that not all of us are in a position to be doing something with muddy soil right now, in potentially your beds or bedrooms or kitchens. But if you did want to do this, please feel free. If you want me to pause the class for a bit so you can go outside in your garden and collect a sample of soil, let me know. You can let me know in the chat, but otherwise I'm going to describe to you what this ribbon test is about, as well as refer you to a few really good resources and handouts in the student handbook that will help you identify the texture of your soil, either yours or a client's soil, by feel, by doing a ribbon test, and by generally using your senses. And so for an example of a ribbon test, and I'm just going to quickly check okay, just checking the chat, making sure there was nothing I needed to read. So the way to do a ribbon test is you take a handful of soil in your hands. Usually, if it's dry soil, you're going to add some water to the soil until it gets a little soggy, not muddy, not dripping, but you want it to start to bind together. And you're going to squeeze and knead the soil till you've broken up all the lumps, and add water till it's like a stiff cookie dough is the consistency. After that point, you're going to squish it into a ball, and you're going to open your hand to see if it keeps the shape that was made by your squeezed hand, which is called a cast. And if it immediately falls into pieces, this will indicate that it's a sandy texture, or that it's like still too dry. So just make sure you have enough water, that there's enough moisture. But if there's enough moisture in there and you still break it up, you open your hand and it just falls apart, you have a lot of sand in your soil. If you break it up and it's still in that kind of shape, but then if you poke it, then it starts breaking up, then you have more of a loamy sand. If it deforms around the tip of your poking finger, oh, let's see, what does it say? If it just, it may be sandy loam unless it forms a ribbon. So if it forms a ribbon, meaning that it is so malleable like clay, like Play-Doh, and that you can squeeze thinner and thinner strips out of it and it's keeping its shape, then you definitely have, you have clay. If it's, oops, if they're really short ribbons and they're breaking off, then like it's still loam, but if you can run a consistently long ribbon, then you have clay. And so the next thing will be a video of somebody doing that, so that you can get a feel for what I'm talking about, rather than me just reading and telling you about it. But the video, unfortunately, last time we tried to play a video, the sound was really bad. And so what I'm probably going to do is mute it and narrate it for you, and put the closed captioning on so you can also just read along. This woman is actually in Australia, so this is something that's done regardless of where you are in the world. She has a wonderful accent, which I won't be able to replicate for you. But let's see if this will show. Okay, you know what? I luckily have this as ready to go as a backup here. Whoops. Nope, that wasn't it. Where's my... Forgive me while I deal with the tech.
Did everyone catch the question in the chat, and why do we use detergent to separate the soil? Did everybody see the answer to that?
Oops. I see all my searches.
Great. And please remember to mute yourselves so that we can get better sound for everyone involved.
All right.
So someone said no. Okay, so the reason that you put in the detergent, the soap in, excuse me, in the jar is that it helps to separate the different types of soil that you have in the jar. That's it. It's better than just plain water.
Alrighty. Okay, so now we're gonna see, can we all see this lady? Yes. Anyone who has a, just nod your head. Okay, so I'm gonna play her little video. And so she's gonna talk about the soil composition. And if for some reason nobody is seeing it or it's not working, you know, let me know. Ooh. Okay, so there she is in Australia talking about soil texture, sand being the coarsest and clay being the finest. And can you all see the closed captioning? Okay. She's talking about also two ways to do the soil test. One is actually to take it to a lab. That might be beyond the either financial or know-how of, oh, something's going on. Oops. Whoa, something's happening.
We figure out what that's happening. Someone said it was to clean the soil. So there is a distinction between dirt and soil. Dirt has no nutritional value where soil has nutrition. And Catherine covered earlier where the deeper the soil, the darker the soil, the more nutrition it has.
All right. You guys can see her using the water bottle to add water to the, I'm using your face, Brenda, as like a guide as to whether the video is working. Yes, happy face. Okay, good. Thanks. So it takes a while to make this kind of like Play-Doh in your hand. And so interestingly, in Australia, they have very like, I don't know if it's everywhere, but very red soil. And she's closing her eyes and talking about how you can use other methods of figuring out soil texture, including putting it up to your ear and listening for the crunching of the sand particles, that you should really use all your senses. She's saying clay is very sticky, and silt, if you have a lot of silt in your soil, it will stain your hands the way that she's showing her hands being stained like this, and it feels silky to the touch. So silt and silky, it sounds like the same word, so that's a good trick. And so now she's talking about using your thumb and kind of the side of your index finger to form these ribbons. So this is what she means by a ribbon. And if you push the ribbon out and it naturally breaks off, then that's more of a loamy clay, versus if the ribbon continuously is able to just be a ribbon for a really long what is it, 2 or 3 centimeters maximum. If it's more than that, then you know you have clay. So now she's just finishing up her little statement, which I think now the content is done. I'm just going to stop the share. Yay. But that was just so that you guys can see the feel. Is this? Okay. All right. Just move there. Okay. So any questions about doing the ribbon test? Because I do also want to point out 2 other little like diagrams that are in your handbook. So loamy is a mixture of sand and clay. It's like silty loam. It's a nice like kind of combo of a lot of the features. So loam is usually can mean kind of the silt part, but it's kind of it has some clay, like if you refer back to the other triangle, loam is kind of like in between, where it doesn't have too much clay, it doesn't have too much sand, it doesn't have too much of anything. It's just like the really nice combo. Okay, so in your student handbook, if you go into the soils section, you will see a few diagrams. You'll see the little triangle, soil texture triangle. And then you'll also see this little diagram of doing kind of a ribbon test, where it looks like somebody's holding dog poop, to be honest. And it's describing the 3 different textures if you had only clay, only silt, and only sand. So keep in mind, this is not a realistic soil to be testing, because you're rarely just doing sand, you're rarely just doing silt, and you're rarely just doing clay. You're usually doing a combination of all of them. So the really, really helpful chart is actually going to be on the next page, which is page 34. And this is a flow chart that basically gives you the soil texture just by feel. So you have the soil in your palm, you add water, you knead it, and then does the soil remain in a ball when squeezed? Yes, then go to this section. No, then go to this section. And you basically just follow it, saying the yes or no answers.
Catherine, are you moving slides?
I'm not, I'm just talking.
Okay, good. Thank you.
Thanks. Thank you for checking. You basically will just move with the flow chart and determine what it is that you want. This isn't on the slideshow, which is why I'm just kind of like pointing it out in my little window and letting you know to either access it at home via your virtual copy of this handbook, or physically, if you can, look at it now, you're welcome to. But that's a really good resource if you're ever confused and you want to be able to just use that, testing it by feel. So next is going to be talking about infiltration. So we talked about soil texture, and now we're going to talk about infiltration. Infiltration means the ability of the water to kind of like pass through the soil. And so if you can look at this chart, this is an infiltration chart showing pore space, different sizes. So the bigger the pore space, the faster the infiltration, the smaller the pore space, the slower the infiltration. So pore space can be small because the particles themselves are small and fit together in a really kind of compressed way, or it can be really compacted soil that otherwise might have bigger pore space if it wasn't so compacted. So, but pore space is kind of your indicator of whether material and water, for instance, can pass through the soil quickly. So to give you a good impression here, on the left is a chart showing the gravitational pull that a soil that has large pore space has on water. So for instance, if you water sandy soil, within 24 hours, it's gone to a depth of 72 inches. So it's usually just like gravity itself that's going through all these little negative spaces in the soil itself that's bringing the water through and giving it nice deep soak. It's also not going very wide. Why? Because it doesn't need to, because it has all this empty space that it can pass through. Small pore space in particularly clayey soils really kind of absorbs a little bit more by capillary action. And it takes significantly longer to get to the depth that you would get with sandy soil. So for 72 inches of water penetration, it takes twice as long, 48 hours, to do the same thing. But you can see that it goes 2, if not 3 or 4 times as wide. Why? Because it's not just gravity that's pulling it down, it's capillary action. So it's actually just the particles themselves. The water has to kind of pass through in a side-to-side motion in order to actually get absorbed. Why? Because the materials are like little plates or like sheets of paper. I think Claire gave this really good analogy of water passing through, say, a ball pit at Chuck E. Cheese or something like that. Like, how easy would it be to just like dump a bunch of water through that and it would just go all the way to the bottom, versus a pit of sheets of paper stacked on top of each other. You pour water on that, it's going to sit on the top forever, and then like just little by little it's going to pass through the tiniest little kind of cracks side to side and finally make its way down. It's going to take a lot longer. So that's kind of a good example of the difference between how water infiltrates soil when you have sand or large pore spaces versus something that's clay, where the texture is just like really kind of, there's smaller spaces, and the material itself is flat and on top of one another. Somebody gave an example. Think of sugar versus flour if sugar didn't dissolve. So a percolation test is another really easy way to test kind of infiltration rates. So we talked about doing obviously a texture test by feel to figure out your soil texture. Now this is about percolation and infiltration. So texture and infiltration are the two things that are going to be the most important kind of hands-on, very practical things that you need to know when installing a new garden, selecting plants for a particular site in particular, and then also just maintaining. It's important to know what kind of infiltration you have. So the way that you evaluate the drainage, basically what we just call also drainage, is you dig a straight-sided hole about 12 inches deep and 12 inches wide. You can think of it kind of as the size of a pot, like a 1 gallon pot, deep and wide, but like 12 inches, a foot by a foot. Dig a hole and fill that hole with water all the way to the top, and then time how long it takes to drain. So sometimes you'll end up with, let me see what the next slide is in case I'm going to cover stuff that's, yeah, all right. So if it drains really fast, within 30 minutes, like say it's even like 5 minutes, 10 minutes, 15 minutes, 20 minutes, you have sandy soil and you're considered to have fast drainage. So rooting is usually deeper in well-draining soils. So rooting is deeper, but the soil itself sometimes dries out faster because it has larger pore space, right? So it's open to more air. Medium drainage is about 30 minutes to an hour if it takes that long to drain. So you can definitely still plant most plants, even plants that are tolerant of clay. You can certainly plant them and also require, faster draining soil will probably still be okay in that scenario. And then where you have slow drainage or heavy soil is the term, then you're said to have clay soil, and that takes more than an hour. So if you have an hour, 15 minutes, 2 hours, 3 hours, half a day, then you have really heavy soil, and you have to be much more careful about what plants that you plant in that scenario. The heavier the soil, the slower it absorbs soil, and the the slower it also releases water. I said soil, I meant water. So the slower it absorbs water and the slower it releases water. So it has a potential, number one, not to get enough of a deep soak if you don't know kind of how you're irrigating. And it also has the potential not to be releasing the soil. Releasing the water. I keep saying soil. This is a soils class. All right. So what does that mean as far as maintenance is concerned and as far as your work is concerned? So sandy soil, high mineral matter, generally, higher air and in the soil, or in the soil. Clay soil has less air and more water, holds on to water. And compacted soil has a lot less room for air and water. So that's really a problem, regardless of what kind of soil you have. To have it highly compacted really causes some issues. But for sandy soil, if you have lots more air, then you will have a lot more opportunity for evaporation. In clay soil, if you have a lot more water and a lot less air, you have less opportunity for evaporation. In certain scenarios, it's better to have faster draining soil that evaporates faster than soil that gets waterlogged and won't let go. And so the water holding capacity is something that's really important. Clay soils have a high water holding capacity, and sandy soils have a low water holding capacity. But because clay soils have a high water holding capacity, sometimes they can become vectors for waterborne disease for your plants. So sandy soils will require a little bit more irrigation because they'll evaporate. After you water them, the water evaporates quicker. But that cycle of kind of water and then drying, water drying is healthier than just staying constantly soggy. Nutrient holding capacity is tied with water holding capacity. So the larger surface area of clay particles allow clay soils to hold more nutrients than other soils as well. So generally clay soils are more nutrient rich than sandy soils. Native plants on the whole thrive on lean soils, meaning soils with low nutrients, not high. So high levels of compost, high nutrition, that kind of gardeny, deep, black, rich soil is not necessarily going to be long-term beneficial for native plants. It might appear that way in the beginning. You'll plant them and they kind of thrive in a temporary manner. But ultimately, you want to match them with the kinds of soils that they might be naturally living in their native environments. For California native plants that thrive in clay soils, they are adapted to the higher level of nutrition, though. So you just don't want to match a plant that's meant to be growing out of a DG hillside and plant it in a flat kind of clay scenario. So you just want to make sure that it's the right plant, right place, which we talked about a little bit earlier in plant selection. So just a little bit sum up of soil qualities. The higher the infiltration rate means sandier soil. It's moderate infiltration in loamy soil and slow infiltration in clay soil. Water holding capacity is highest with clay soil, moderate with loamy, and low with sand. Same with nutrient capacity, but the aeration of sandy soil is good, moderate with loamy soil, and moderate to poor with clay soil. And aeration, again, yes, it exposes the roots to oxygen or exposes the roots to drying out potentially, but air in the soil is actually oxygen is actually essential for root health as well. So anytime if there's zero air in the soil, that's a recipe for disaster. So just a tip, sometimes a garden is planted without knowledge that the soil is heavy clay, and you might be replacing plants over time that aren't thriving. And so that's just a natural part of garden maintenance and the evolution of a garden is that constant repair of past mistakes. So you might find that this is a soil-based mistake that you have to plant things that are going to be adapted to clay. So pathogenic activity, pathogenic refers to disease. So soil pathogens are microorganisms that cause plant diseases when the spore, cell, or fungal hypha invades a plant by way of the soil. And so this is a nice kind of diagram of the soil food web. And so when we're talking about first trophic level right here. We're talking about photosynthesizers, which we're talking about plants, plants and their roots and their shoots. The organic matter, waste residue from the plants, animals, and microbes is something that bacteria and fungi feed off of. So fungi and bacteria sound bad, but they're actually essential. It's just that you can sometimes get pathogenic fungi or pathogenic bacteria. But on the whole, when we talk about fungi and bacteria and all this activity, it's a positive thing as long as the whole food web is kind of activated and you have a healthy balance. And so of the fungi, we have mycorrhizal fungi and saprophytic fungi. So saprophytic are the decomposers. So those are the ones that will, say leaf litter falls on the floor and it starts to degrade, and then you have little fungi who are kind of eating the dead leaves or dead wood. You see mushrooms on decomposing logs in the woods. That's a saprophytic fungi. And so mycorrhizal fungi are symbiotic, mutualistic fungi that live inside the soil, that colonize the roots of their host plants, which are many of our, actually, I think it's like 80 to 90% of all plants are mycorrhizal. And so what they do is they will exchange kind of sugars and nutrition and give back water and other nutrition to the plants. And so it's this beneficial symbiotic relationship that occurs that's really, really valuable, especially in the case of like wildland restorations or even urban restorations where we're dealing with soil that doesn't have a lot of kind of healthy biology in it. So you sometimes can inoculate the soil with these healthy organisms. And so, but occasionally you'll get pathogenic versions of any of these things, or not of these things, but of fungi or bacteria, depending on the site. So nematodes, arthropods, the whole food web, as you can see, up to larger animals is supported by this soil food web. And so one of the things that damages the soil food web is tilling. So tilling means breaking up the soil and fluffing it up. So most people are taught to do that to prepare for veggie garden beds or to improve reduce compaction. Say they end up in a site and they think, oh yes, if I fluff the soil up, this is a really good thing. If you have a healthy kind of soil food web intact, your tilling really disturbs that and disrupts that and causes more problems for you down the line. If you're in a highly degraded site that has zero healthy, soil kind of biologic activity, then potentially you could get away with tilling without really like creating a big issue. I'm just looking at the chat real quick.
I got you on chat, Catherine.
Oh, thank you. Okay. All right. So so feeding the soil helps feed the whole soil food web, which in turn helps your plants. And so how do we feed the soil? It's usually by healthy mulch and not disturbing the soil through the process of tilling, and also just planting the plants back that would thrive in that environment. So the roots themselves help to aerate soil and to kind of start this process. So salts can be a negative, and generally there's always a little bit of natural salts, but excessive salts is definitely a negative in soils. And so depending on what kind of irrigation system you have, the salt levels can be a little bit too high. There are native plants that are adapted to salty conditions because they've evolved along the coastline where there is that kind of salt spray and just general salt in the air that ends up in the ground kind of at their root zone. So they have a tolerance for it both on their leaves as well as in their roots. But on the whole, most non-supercoastal gardens, you don't want high levels of salt in the soil. And so fertilizers, hard water, deposits and such can increase the salt. And the thing that really helps make that go away is rainfall. And so you will see oftentimes the plant's health will improve significantly more with rainfall, even if it's the same amount that you water with your regular municipal water. The same amount can happen with rainfall, and all of a sudden the plants are just seem so much more vibrant and alive and healthy and happy. It's because it's kind of like flushed away all of those kind of salt deposits away, and they tend to rebound really quickly from any kind of potential ill health or stress that they're feeling from that. So it's really hard. Occasionally, when I worked at Theodore Payne, you'd have a client or a customer who would ask for, I need plants, but it's going to be planted under a deck, and I'm going to water it so that they're alive. I don't want to not water it, but it's not going to get natural rainfall. It's just going to be artificial rain from the hose for its entire life. And unfortunately, in that scenario, the salt accumulation from the hard water versus rainwater is going to be eventually something that kills your plant. Even if you mimic the right inches of rain and all of that, it is ultimately not really healthy for your plants. And so you want to make sure that in that scenario, if you're desperate for something that isn't going to ever receive rainwater, that you're collecting your rainwater and watering with that instead, or to supplement to kind of flush out the salts. So compaction is a big problem, and nothing really helps compaction more than planting the plants and allowing their really robust root systems to do some of the work for you, and mulching. So mulching and planting is really a great strategy. It's going to be slower than like tilling and artificially fluffing the soil, but it's ultimately going to be kind of a long-term, more sustainable thing that doesn't draw up a bunch of weed seeds or potentially damage the kind of soil food web that's hopefully still intact in there.
Catherine, we had a question from Ari
Yes.
about having tons of weeds and shoveling them out with lots of dirt. Is that bad for the living creatures in the soil? I can't remember if we cover that in lesson 6 for the weeding, or if we just want to give a brief explanation for the moment.
I can do a brief one now, and then we'll do more of it. So we have a weeding and weeds and kind of pest management IPM course, so we can get a little bit deeper into it. But generally speaking, the more soil disturbance that you generate, the worse off it is, both for the soil health, but also for weeding itself. So weeding, weed seeds are in the soil bank. And so every time you draw up a root system from weeds that you don't want, and it carries with it a ton of soil, and it kind of disturbs the ground underneath, you're actually bringing up future weeds. And so it's generally not a good idea to disturb the soil as much. I tend to still pull weeds, but if I know huge clumps are going to come up, and like just wads of soil and roots are going to come up with every single weed I pull, the better strategy in that scenario, if it's an annual weed, is to just repeatedly cut it down until the season comes where it just naturally dies out and it did not have an opportunity to flower. So for instance, it can be a little bit hard. The timing has to be right, and you have to be kind of on top of it to make sure that it doesn't have the opportunity to flower, because that's how you prevent the weeds from coming back. But generally speaking, yes, the less disturbing of the soil you can do, the better. If you can cut it either right below the soil line or right above the soil line and not draw up a bunch of stuff with it, that's better. If you have no other option, then you have no other option. And I think, it's better to remove the weed than to leave it. So I hope that answered it temporarily, and we can, like I said, get more into weeds later.
Yeah, we have a lot of questions about soil and soil turnover, et cetera. We're almost at 7 o'clock. Do you usually take a break?
I don't, but we can, because I think we should.
Thank you, Robert. And thank you for the slide and all the information that you and your crew put on there with the how to use the Juncus.
Yeah.
That was pretty cool. I mean, we have ethnobotany courses here, but we don't do them. TPF staff usually doesn't do them. We hire, indigenous people to talk about indigenous uses of plants. So.
We should all take a field trip to your site.
I vote yes. I vote yes. Are you ready for us, George? I mean, Robert?
You said yes. Yeah, field trip.
You name the time and I can arrange it.
That would be so cool.
It would. I was out there. I was in Palm Springs, and that's how I met the excuse me, not the ethnobotanist. Robert, who did I meet? It was the tribal. I can't think of her name, and I feel so bad. But I made contacts with a lot of the tribal people out there. Jessica, thank you. So that we can, get more of this, how to take care of native plants back into the hands of the people that somehow lost the knowledge of how to do all this stuff. So it's kind of coming full circle. And Robert and everyone from the staff, thank you for being here. Thanks to everyone for being here. And who is it? George had a good point. There is a class coming up that Carol Bornstein is teaching about plant ID. We're opening it up to people that have already gone through this program. If it does not sell out, then we'll open up to current enrollees. So keep an eye out for that. And thank you, Robert. Jessica, Culture Awareness Management, and I should remember her title.
And I'm wondering if Emily has a cat.
I saw that. And at first I thought it was me. I'm like, oh my goodness, am I doing that? Because I'm eating cookies here. And I'm like, oh.
She said, oh no.
Yeah. So I think Emily's cat does not like the class.
Or loves the class. I can't tell.
I don't know. That S right there, the fives look like S's to me. So I think that means no.
She has two cats, apparently.
Right. Random question. Is there any California native plant that has effects similar to catnip? I would think no, because cats are not native.
Correct. But I think, I don't know. I'm trying to think if there's anything that I've ever brushed up on or was, touching that my cats reacted to. The only thing my cats go goo goo gaga for is olive wood, but it's not native. My dad's a woodworker. Anytime he has olive wood shavings or even just this is a coaster I made with camphor, again, not native, from street tree prunings. And my cat drools on it all the time, which is kind of disgusting. But and so worms are not native. The earthworms,
we have some worms
not native, but earthworms, the usual ones you're thinking of, came on the ships, and actually are some of the have become an invasive kind of species without people thinking of them as invasive. They've actually been one of the reasons why a lot of the old growth kind of forests on the east side of coast are the leaf litter and such is kind of being decomposed and eaten at a faster rate, which is actually harming the forest.
Yeah. And then someone had a question earlier about bringing in plants from out of state, and that's to a bigger picture of when you bring in exotic plants that are not native. They don't necessarily do immediate harm to the ecosystem, but the long term is that they don't have the insects and birds and everything else don't have the adaptations that our native plants already have with the microbes in the soil and the insect life that co-evolved. Think of monarchs and milkweed. The Joshua trees have a Joshua tree moth that is a pollinator, and yucca, excuse me, and the yucca moth, that's its only pollinator. I can't think of other ones, Catherine.
Those are good examples. I think that the other thing too to think about though is our states are man-made boundaries. There's no such real thing as, California. There's no, the plants that are on the border of California and Nevada aren't like, oh, now you're Nevada's plants, so plant communities and are a lot more flexible than the kind of rigid lines that we've made. But anytime you do get something like you brought something over from, Japan, or you brought something over from, really far away, or somewhere where there's not even a similar plant, that's when you run into probably the biggest issues.
Yeah, and with our bees especially, we have over 1,000 species of California native bees. That's all they do is pollinate. So when you take away the California native plants, that's a huge impact on the ecosystem.
And the one bee that everybody is talking about, Save the Bees, is actually not even from North America.
It is a colonizer bee, Catherine.
And they form colonies too.
Exactly. It is 100% the definition of colonization.
Yes. Yeah, so it's actually considered livestock in the scientific community. They're considered livestock. They came for agriculture reasons and then escaped and became an invasive species. So a lot of people are like, I love bees, and you should love them for the same reason that you should love all the California bees. Sorry, my cat is causing trouble here too now. Say hello, this is Peach. Hello,
He's
everyone.
starting a war with Emily's cats. Cat fight. So anybody?
Anyone else have animals they need to deal with? Oh, we're past the point. All right.
Yes, we're past. All right.
All right. Thank you. Panini. Oh, their cat's name is Panini. Peaches and Panini sitting in a tree. All right, let's do this. Now we're on to managing soils. So this is where you guys come in. Come on, there we go. Okay, so the best thing you can do with regards to soil health is mulching. And so mulch is any kind of, I'll correct that, but shredded like material mulch, like actual shredded wood, chips, bark, etc. versus rock mulch isn't going to help your soil necessarily, but we use the term mulch to kind of cover any kind of like top dressing onto your soil. But in the case of the LADWP rebate program, or in the case of where you're trying to improve the soil health of a site, when we talk about mulch, we're talking about natural wood, tree, byproduct type mulch. So shredded bark or shredded wood chips. So compost is different than mulch. Compost is all of that stuff. It's like green waste that's been decomposed already. Mulch has not yet been decomposed and does the decomposition process on the soil. And so if you're going to be doing any of those LADWP rebates, you are required to have 3 inches of organic mulch on top of the soil as part of the program. One thing to keep in mind, however, because we were just on the topic of bees, we talked about in the very first class, we did a kind of your first year, second year, third year of the garden. And then we finished off with somebody's garden where they didn't use any mulch. They used decomposed granite as their mulch, sort of, and as their planting kind of top dressing. And so that site had tons of native bees, because our native bees, many of them are ground nesters. They don't form the beehives like your European honeybees. They nest in the ground. They make little holes in the ground. So your sweat bees do that. I'm just ignorant of too many, but because I actually had sweat bees in my yard, I know them for sure. And so what they do is they create little holes in the ground. They nest in there and they come in and out, and you can see them in the summertime buzzing in and out. They're not dangerous. They don't cause issues. But if you want to create habitat for a variety of species, which I hope you do, not just one kind or another kind, it is good to leave some areas of bare dirt. And that could be still a place that you put wildflowers and you still plant it. Not that it has to be like solid bare, looks like beach sand or something, but just not putting mulch over certain areas of your yard and putting mulch in other areas. For LADWP, I think you have to have it on most areas, but conceivably a pathway that's just DG not stabilized DG, but just regular DG would still be something that the bees could probably nest in. Though I don't know if you want to be having them nest in something you're walking on. But that's mulch. So let's talk about mulch. Why do we use mulch? It conserves moisture. So anytime you have a top dressing on something, it keeps the evaporation from happening as quickly from the soil. So it's like, imagine you watered and then you put a blanket over it. It's going to be much, it's going to retain the water much better than if you had it exposed. So it creates kind of just like a blanketing effect. It reduces weed growth with that same mechanism. So it smothers weeds. So weeds that need to access sunlight find a barrier. And so some of the stronger weeds will still poke through, but the weaker ones will kind of just get smothered and die. So it does reduce weeds. So having kind of that suppressive quality as far as weeds is a good thing. But keep in mind that exact same strategy will reduce wildflowers as well. So weeds and wildflowers kind of operate with the same mechanism of needing sunlight and using that one season's available water to complete its whole life cycle. And so anything you're going to be doing that's going to be reducing weeds will also reduce wildflowers, and vice versa. Anything you do to support wildflowers will also potentially support weeds. So you're learning to identify the different weeds versus wildflowers, and picking out the ones over the others is smart. Also, just designating particular areas of the garden for wildflowers rather than trying to do this. I'm going to have a wildflower meadow over my whole, yard. That can become really challenging. So mulch alters the chemical and biological composition of the soil to some degree. Nothing crazy, but it does start to help change the soil kind of biology inside, because again, you're introducing a decomposition process, which again triggers other fungi and other microbes into action, and that starts to change the chemistry of the soil from underground. It indicates pathways or focus points. So you could use mulch as a pathway surface. So conceivably you could use it as a walking surface, or it could be the opposite, where the mulch is in all the planter areas and everything that isn't mulched is a pathway. So you can use it just as a design element to divide sections of the landscape, and so that you kind of know where you're supposed to walk through, where you're not, etc. Creates an interface between different garden functional areas. Gives the garden a more finished appearance, and this is very true. If you planted a bunch of stuff and there's just dirt and plants, it doesn't look quite as nice as when it's covered with a top dressing of mulch and there's that kind of uniform color. And mulching trees and shrubs can recreate some aspects of a forest soil environment, even in a sun-baked landscape far away from any forest. So that kind of heavier leaf litter kind of quality that has a little bit higher organic matter, you can kind of mimic that. And if you do have any larger trees or have any kind of partial sun scenarios, you can kind of replicate that, that look. All right. Definitely 3 inches of mulch is too thick if you're going to do wildflowers. Literally, you want no mulch or just the tiniest, amount of just like maybe just so it looks decoratively there, but it's very easy to still poke through if you're doing wildflowers. So if you're trying to do this in tandem with the DWP program, you might find some challenges. I would just, not forego the wildflowers for a while. And then just designate specific spots for it. So different types of mulch type matters. So tree bark is kind of the best. And there's different varieties of tree bark. And so you can get lots of different kinds, and the cost is usually quality based. For people who really like something that stays colored reddish brown, they might go for something like a redwood bark mulch, and that is probably your most costly one, but it retains the color for years, and that's something that people go for. It's also generally very compatible with native plants as far as what kind of decomposition process it goes through. But there are lots of more affordable mulches. Decomposed granite can be considered a mulch. So again, that other garden where we featured, I said there were lots of bees going in and out. They use decomposed granite as a top dressing mulch rather than using any kind of tree bark material. It's important with that scenario is don't buy decomposed granite with a stabilizer in it in that context. So decomposed granite usually has a stabilizer in it because it's most often used in pathways where it's intentionally being compacted and you want it to be almost like a natural concrete. And so that's something that's going to become, it's permeable technically, but it's going to be very compacted and kind of bound together, and going to be impervious to plants really growing in it. So if you want to use it as a mulch around plantings, you want to make sure you're buying stabilizer-free decomposed granite. Rocks and gravel are also used in landscapes, so they work very well in a desertscape with desert plants. And the issue with rocks and gravel can be that, number one, it can heat up really hot and heat up around the plants and kind of just make your yard feel a lot hotter than it needs to be. So depending on where you're at, it might not be the best choice. The other thing is it's harder to weed through gravel because the weeds find the tiniest little nooks and crannies and come out, and it's sometimes hard to get the weeds out. It's kind of the perfect environment for weeds to grow through. And then the other thing about it is that it is very hard to get rid of if you ever change your mind. So at least tree bark will decompose, or you can rake it away if you ever change your mind. Rocks and gravel are very cumbersome to move. So when you put them somewhere, be sure you want them there forever, because that's ultimately what's going to happen. The other thing that's a real challenge is when organic matter does fall into it, which is almost always natural leaf litter from your plants, tree litter from the leaves of an overhanging tree. When they start decomposing, they start to create their little own pockets of soil because they're literally decomposing on the rocks. It tends to look a little messier, but it also creates these almost little soil containers that weeds grow in very easily after that. So I would say be cautious about using rocks and gravel in a big amount, in a big way. It's really effective and really important to use in fire-wise landscaping, like along the 5-foot ember resistant zone that you should maintain around a house that's in a wildland kind of area. So it's definitely useful as an attractive feature and as a mulch in a scenario where you can't have anything combustible. So use it in those ways, really effective, but for widespread application across your whole garden, I wouldn't do it personally. Natural leaf litter is 100% okay to leave on site. In fact, there's that little phrase, leave the leaves. And that is a really good practice, is to allow natural leaf litter to accumulate to some degree. If it's something like a sycamore tree that drops and blankets over your whole landscape, you may think twice about keeping that on site if it's actually smothering your plants. But otherwise, natural leaf litter will just decompose in the landscape and become part of that soil food web.
We have a question in the chat about gravel specifically affecting roots. My reaction would be it shouldn't, because the roots are growing down and out, not at the top. But this had to do with citrus. But Catherine,
I wouldn't say that it would impact the roots in a way that would cause harm, unless the roots are really superficial and the gravel's getting really, really hot. That could be a potential issue. But otherwise, I would say it's probably not a problem. It's just that it's not going to be any particular help for a citrus tree or any other tree. It's not adding anything to the soil. It's not necessarily supporting the food web. It's kind of, I don't want to say it's killing the soil underneath. It's just not activating it with natural process of decomposition and such. Underneath the gravel, it's nice and cool. That's good. So if it's not heating up, then don't worry about it. This is more of an aesthetic choice. It's not really feeding the citrus tree anything compared to what, you know, natural leaf litter or tree bark mulch might do over time. But I wouldn't say it's like actively harming it. Somebody also, Jack noted that in a nursery setting too, oftentimes the grounds of underneath nursery tables and such are all gravel, and leaves naturally fall, or dirt from the pots will naturally fall into it and get kind of caked in there, and so he has to vacuum it out. And so that's, he says it's so fun, which I imagine is not true. And so yard waste is another thing that you could conceivably use as a mulch. So a lot of the city has, LA Sanitation has kind of a free mulch giveaway kind of a program, and it's used from everybody's green waste bins. The premise of it is fantastic. The actuality of it is less fantastic because oftentimes you don't know what's going in everybody's green waste, whether it's chemically treated plants and things, whether it's weeds, a lot of weed seeds end up in that free mulch, and different kinds of fungi and such. So I don't want to say I made the mistake, because I still highly value that program, and I think the idea of that closed loop processing everything and repurposing it is of major value. But I did that once and I ended up with weeds beyond that I've ever seen before, things that never were in my yard before. Dog vomit slime mold, which if you've ever seen is like this yellow foam that shows up and then it's hard, and then the spores are released, and then so like dog vomit slime mold started showing up in my yard, never was before. So it's free, but know that you get what you pay for in that scenario. And there are some places that are better than others. And so, for instance, LA Sanitation runs a mulch and compost kind of giveaway program out of Griffith Park. And they use tree waste from Griffith Park. So it's mostly like actual tree product, really clean, really high quality stuff, versus maybe something that's people's residential green waste and you're picking it up from North Hollywood or something like that. Where you get it from and what thing they're processing matters. So even though it's the same kind of program. So just keep that in mind. But free is great. The other thing that's cool, and it's just not available to residential people easily, but if some of you are landscape designers and architects and such, and might have the ability to get this resource. But LA Street Services, the people who do the street trees and the sidewalks and all of that through LA City, they recycle 100% of their tree trimmings or tree removals into 3 different like grades of mulch. This really like fine, and then like a slightly coarser, and then a thick coarse mulch. And they will deliver it to any kind of site or park or anything. But it's like huge truck, dump truck full. So you have to have a real project, not just a residential project, but like a big kind of landscape project. And so you'd be recycling actually just tree waste from the city, which is really kind of cool. And they do that 100% recycling of that and 100% repurposing and recycling of sidewalks. So the sidewalks, when they repair the sidewalk, they take it to their recycling facility in Granada Hills. They break it up into like road base, and then like DWP or whoever needs to use it for materials, they just like keep repurposing it. So 100% of the broken sidewalks, 100% of tree removals and tree trimmings, LA Street Services recycles, which is a really cool thing that not a lot of people know about. So again, it's a cool program to do, the kind of like the yard waste or the recycled or free mulch, but be aware of where you're getting it from. So post-consumer paper is often used. So that's usually in like sheet mulching and such. I think there's like an example of that later. Petrochemical products, definitely don't do that. And gorilla hair mulch is not recommended, especially in fire-prone areas. I've used gorilla hair. I find that it's one of the better ones to do on a steep slope. If you're gonna do, but in fire territory, don't, because the hairs, the actual shredded, it's shredded redwood bark, and it's shredded in a way that's kind of like hairy, and it kind of catches fire more easily than other mulches. But on a slope, because it's that kind of texture, it sticks to a hillside a lot better than other mulches. So I have used it in that scenario pretty successfully. So we'll just do a little bit. Richard says gorilla hair looks beautiful. It's very kind of red. Greg Rubin would disagree. We're having the native plant expert battle here. Doesn't he like? Anyway, I don't know. Maybe I don't know my Greg Rubin well enough. So tree bark's another shredded wood material, is kind of just the best thing. And again, this is what's required for the LADWP landscape rebate. So you have to use tree barks or other shredded wood material. You can go to, if you want to pay for it, you can go to Soil and Sod Depot. You can do forest floor mulch, they call it, or just simple brown mulch. What you don't want to do, please don't go to Home Depot, maybe ever, for mulch. I don't think I've ever seen a good Home Depot mulch. Most of Home Depot's mulches are just like shredded chunks of lumber that they've spray painted some color, either brown, red, or black. That is garbage. So don't ever use that. That does not add anything nutritive to the soil. That barely decomposes. That's probably covered in paint chemicals. And it's unfortunately used all the time in landscapes. So please use something that's just as natural product as possible, as little removed from the source as possible. So again, decomposed granite, 2 to 3 inches. It can help retain moisture in the soil, but it's almost like sand. So it's not going to be as good as far as moisture retention, I think, as your bark mulch, but very useful. This and gravel, very useful for that 0 to 5 foot zone next to the home as a non-flammable mulch. So anytime you're planting, if you are, and this is an added expertise that you can provide a client that lives in a wildland interface zone or in a high fire severity zone, is to be able to landscape their landscape according to the FireWise practices and sustainable defensible space kind of protocols. And so the main one that has been found to be the most helpful in preventing house fires from wildfire is to have a 5 foot non-combustible ember resistant zone around the house. That most fires of house fires regarding wildfires in Southern California are ember driven, meaning that showers of embers a mile away from the actual fire falling onto a house is what catches the house on fire, because there's either leaves in the gutters or there's combustible material right up against the house, that it's not the fire itself coming from the hillside and swallowing up this house. It's just little embers that catch something close to the house or on the house itself. So it's the home hardening, and it's that 5 foot zone directly around the house that has the highest impact as far as fire prevention than anything else in the landscape. So that whole 200 foot, we're going to create a moonscape of 200 feet away from your structure to prevent you from having a fire is super backwards. And so decomposed granite or gravel can be very useful to create that non-flammable, non-combustible space directly around a house. So gravel mulch is not allowed by the rebate program. As far as like, I think widespread use, I'm sure you could use it in very small spaces. Like if you have like teeny planter and you just want to put a little bit, that's fine. But on the whole point is that you're going to be putting a 3 foot layer of the wood mulch. And you can use obviously the gravel mulch inside a swale or a dry creek, any kind of like rain garden or something like that. That's very useful. You don't want mulch, like you don't want tree mulch in that scenario. So just regular leaf litter, in case you don't know what it is. Pine needles, oak leaves, the natural leaves that slough off of your plant. So this picture has a white sage. This is all the natural summer slough. I like to call it the summer slough. I just invented that just now. So when it becomes a thing, you guys are the first to hear it. So the summer slough is when drought tolerant plants lose their winter leaves because it's hot and dry now, and so they're just conserving their smaller, tighter leaves, and they're letting go of all those big floppy winter leaves. And that's what you're seeing on the ground under the white sage. So I mentioned it, that ceanothus does that. Manzanitas sometimes do that. Sages do that. Lots of those plants do that. So it's that summertime sloughing off of leaves, and that leaf litter naturally will decompose underneath the plant, can inhibit weeds. In fact, we found, my colleague Asher and I made a note while we worked at Theodore Payne in the nursery. It was very rare to find weeds in the ceanothus pots. So we were always weeding in the nursery, like there were always weeds throughout the nursery, and that was one of our tasks, was to pull the weeds out of the pots. Ceanothus, no, did I say ceanothus? I meant salvia. Sages, the sages, those pots with their sage leaves blanketed inside it, rarely if ever allowed a weed to germinate in there. So I don't know if it's the sage composition of the sage leaves itself, whether they were resinous, aromatic, what it was, or whether it was just that, you know, they had that natural leaf litter and it created just a top dressing that suppressed it really well. But it's kind of useful to leave it. If leaf litter ever piles too high or is kind of smothering the stem of the plant, feel free to pull it away. You also don't want just things decomposing against the stem. Or the root crown, because that could lead to, you know, negative, you know, pathogenic situations. But on the whole, leaf litter is a good thing to leave. So yard waste, grass, hay, straw. Generally, these things are weed infested, seed infested materials. So if you know 100% that your grass clippings didn't have any seed heads on them, and you want to just let them decompose, it's usually better to just put it in your compost bin and recycle it into maybe like raised bed veggie gardening or something like that. If you had to throw it around your garden, you could, but ultimately it's better not to have this in a native garden. So this is your shredded post-consumer product, sometimes even not shredded, depending on what you're using. So sometimes you can put full sheets of cardboard. You could put this down as a way of killing off the weeds and then put mulch, wood mulch on top of it. Eventually this part will completely decompose into the soil. I will not say that it adds any particular nutrition or benefit to the soil itself, but it can be useful as a weed suppressant if you need to just handle all the weeds. You have a big weedy scenario and you just need to smother it with total blackout. Cardboard is better than black plastic. But again, we'll get into some weed strategies. So solarization might be an option in that scenario, but a lot of people swear by sheet mulching. I haven't personally done it, but I see the value in repurposing kind of garbage material that hopefully isn't like the inks and such aren't toxic. So you're not supposed to do, I think, colored, glossy kind of magazine pages necessarily, but like regular newspaper or cardboard is usually safe to do and will kind of tackle your weed issue before, and in a way that's far preferable to the actual weed cloth. Though I think weed cloth is required for the LADWP program, which is kind of unfortunate because it messes with the soil culture and it actually creates a barrier between the mulch and the soil where you actually want all that interfacing to happen and you want the soil health to be improved by that activity. So that's a little bit of a challenge. Maybe they would accept cardboard. I don't know. Oh, and somebody says, make sure you take off the tape from the cardboard. Absolutely. Please do. All right. So next, petrochemical products. Doesn't that sound wonderful, guys? Doesn't that sound like something you want in your garden when you hear the term petrochemical? rubber bark, fake bark that's made out of rubber. Please don't ever put this in your yard. Don't ever treat it around soil that has plants living in it. The only place for something like this is like a playground, where you can't have natural mulch or something like that. But even that, I've been to Libby Park. They've got natural mulch all over that park, and it's amazing. So there really isn't a scenario where this is valid in most landscapes, I would say. So how much mulch do you put down? 3 inches. A 3-inch layer is generally the rule of thumb. You can do 2, but for the rebate program, you need to do 3. Over time, it's going to degrade. You know, so don't freak out if you're like, I put too much, it'll go away faster than you think. But make sure you're not piling it too high against the trunks or the stems of the plants, because you can rot them. Again, you're facilitating and encouraging a decomposition process with mulch, and you don't necessarily want your plants decomposing along with it. So just be aware of that. Just leave a little bit of a little space. I like to make a reference to, what's his name? Mitch Hedberg. He talked about turtlenecks and how he doesn't like turtlenecks because his neck is fragile. And he says wearing a turtleneck makes him feel like a really, really weak guy is trying to strangle him all day long. And so he wears like a V-neck all the time. And so I say mulch on the stem of a plant is like wearing a turtleneck all day. Just, you know, make sure there's like a little bit of a collar, make sure that this part doesn't stay wet, doesn't stay kind of dank with decomposing leaf litter or tree bark. All right. Amendments, just say no. Healthy soils don't need additional fertility. Usually your fertilizers add temporary benefit or temporary appearance of benefit, but don't actually create a sustainable healthy kind of system for your plants. So it's not recommended to fertilize your plants. It's better that they go kind of like slow and steady in their growth pattern than go, yeah, gangbusters, I just had all this nutrition, and then collapse because they can't sustain it. And so it also encourages weeds. The more fertility you put, the more it favors those kinds of fast-growing ruderal kind of species. And so you don't necessarily want that. So we recommend you kind of keep your soils lean and mean the way they are naturally. Also, changing the soil texture is generally not advisable. So digging, tilling, fluffing up the soils to create larger pores is only a very temporary fix that really just brings up more weed seeds and creates a bigger problem down the line. So we don't usually recommend trying to change your soil texture or trying to add other components to the soil. It will take many, many years of repeated attempts of changing your soil to even get the smallest fraction of an improvement. And then your wallet, it will be drained, or your client's wallet will be drained. So it's usually better to just make sure you're planting the plants that fit in that soil just as it is. So it's like in a relationship, you don't want to change yourself for the person. You want to find the person that accepts you just the way you are. So that's what you're doing with the soil and the plants. All right. So opportunities for professional consulting and extras related to this and related to the soil health. So first of all, name this plant. Put it in the chat. Do we know what this is? This purple flowering border perennial. What do we got? What do we got? So somebody recommended verbena. It is not verbena. It is Penstemon margarita Bob. Yes. So Penstemon margarita Bob. So this is the one that I said Bert Wilson at Las Politas Nursery introduced into the trade as one of the most, if not the most popular native plant that is also even sold at Home Depots and such. And so it's also the one I said doesn't really like, I have not experienced that it looks great after 2 or 3 years. So it's really good for those like filler plants that you need. Either you can continue replacing them if you want to keep it there year after year. Otherwise, use it as a filler that you need while the other bigger plants take their time to fill in. So that's something that's kind of nice. So the other thing, how about this plant back here with the white flowers? Also sometimes called fried egg plant. Aha, so we got Matilaha poppy, great guys. And hummingbird sage, yes. There's also hummingbird sage. These flower spikes behind the penstemon margarita bob is hummingbird sage. Excellent, guys. All right, so opportunities for consulting could be with regards to soil analysis. So this could be just part of your natural initial consultation with a new client, where you could either have them pay for you to actually send a soil sample to Wallace Labs or somewhere, or you could perform actual infiltration, soil type, and general kind of health estimates for your client. And so that's generally something you're going to do on your own. If they're requiring you to, not requiring you, but if part of the gig is to plant plants, you have to do an infiltration test. You'll have to do a soil texture test just so that you know what kind of plants to plant in that space. But if that can become part of your package, and you can kind of pitch it to the client and say like, well, I'm going to do such and such tests and tell you what kind of texture you have, etc. That can be kind of a way to show that you're providing this additional service that you could conceivably charge for. So a planned replacement program for mulch. So that's another thing. It could be an annual or every 2-year kind of just routine thing that you put into your maintenance plan, that every year or every 2 years you'll replenish and revive the mulch. So that could be a kind of a regular thing that you do for every single one of your clients. And if you have, say, 20 clients, that can become kind of part of your rotation and generate more income for you.
We're at 7:48.
Oh, cool. I think we're pretty much wrapping up. Maggie says that LA Compost does soil microscopy. It's always the hardest. I actually heard that word for the first time today, so this is funny. Microscopy.
And Ella had a question. The practice of adding mycorrhizae powders to native plants planting hole, thoughts about the practice, and any thoughts on the process of community of native plants developing that association in the garden setting?
Yeah, so native mycorrhizal inoculant is used a lot in certain types of like restoration projects and such. I weirdly have had conversations with 2 soil experts today as part of my day job, literally about this, where I'm going to be participating in helping to grow an actual mycorrhizal inoculant for a project. And so there are places that do that it's just a matter of knowing which mycorrhizal inoculant to use. Arbuscular mycorrhizae seems to be useful in kind of a more generalistic, widespread way for like coastal sage scrub and some other of the more common species, whereas something like an ectomycorrhizae is for like oak trees and oak wood. So there's some specificity to it, so it might be worth like reaching out to an actual pro to figure out which one. But if your site is really degraded, you might consider doing that to inoculate the soil so that you kind of promote that. They require the plants to be in there though, so like, yeah, into the planting hole, or certain nurseries like Tree of Life Nursery naturally inoculates their potting mix, so you get it with the plant. Otherwise, if it's not a highly disturbed environment, you might already have it in the soil, in which case you don't really need to worry about it. So if it's not some urban fill or something like that, if it's a residential yard that has had kind of natural plants and trees growing on it for a really long time, you might not, it might be unnecessary to add.
And a question about engineered soil taken from a site, would you recommend amendments for that?
Engineered soil meaning like fill soil that you're bringing into a project? Is that what we're talking about? Like inoculating sterile-ish soil? If that's what you mean. Yeah, I think there's a whole science behind something like that, where you want to make sure not only that you're getting the right soil texture and components, the actual like the infiltration and texture kind of like ratios right, but also that there's the soil biology in there that's going to be supportive to the plant. So mycorrhizae fungi tends to be, I think, the big one that's going to support that. I don't know if compost in that scenario would also aid in it, or it would kind of detract from it by adding maybe too much nutrition too soon, conceivably. But I will say I'm relatively ignorant with regards to compost. I would say that the possibility that it could be beneficial to get something started to just kind of build a soil kind of biology might be useful in that scenario, but the native plants really do require that fungal symbiotic relationship with the mycorrhizae more than anything. All right. So, planned replacement program for mulch, that's an option for you. Oh, okay, so now we're just at the homework, and I'll actually be able to like talk about it and not rush you through it. And also keep in mind anything that is homework related, or these slides, like little outlines, so you know what we covered. It's all in your handbook, either virtually, online, or in hand here. So if you have any questions about the homework, what you're seeing on the screen is also in the paper, on paper, or on the slides, or whatever you have, if you don't have a paper version. So lesson number 3 is going to be an infiltration and ribbon test. You're going to check the infiltration rate and soil texture at a work site. Let's see. You're going to take a shovel to a work site. And so when I say a work site, this could literally be your backyard. This could be the property you manage. This could be a client's yard. This could be, and I don't want to assume that every single one of you has clients or is already robustly in this career. So if this is, something that you wanted to take these courses because you were thinking of entering into this career and you don't have this kind of like opportunities for, going out to a client's yard or anything like that, conceivably you could find a different space, a friend's yard or something like that, or maybe go to Theodore Payne, see if they'll let you dig a hole in their, oh no, we're not letting you. Don't go to Theodore Payne, but maybe at a park or something like that. So just, I think most of you probably have access to dirt, and it can be in your own yard. So you want to check the infiltration rate and soil texture. So you're going to take a shovel, you're going to dig a pot-sized hole, you're going to take some of the soil that you just dug out, and you're going to put it in your palm and add water to it, and you're going to start to feel and mash it together until you kind of create a cast. And you're also going to do a ribbon test, so see if you can push the ribbon out into your hand. If you can't at all, then you automatically have sandy soil. If you can do it only partially, maybe you have loamy, silty soil. And if you can do these big long ribbons, then you have heavy clay soil. And then so that's how you're going to kind of estimate the texture and note the soil type by that. You can also use this flow chart on your student handbook and do this kind of soil texture test by feel and answer the questions, until you get an actual soil texture at the bottom. And then you're going to fill that hole that you dug in the ground with water all the way to the top and time how long it takes to drain. The thing you want to keep in mind, sometimes really thirsty soils will absorb water pretty quickly. And then the second time you do it, it'll absorb it slower. So sometimes it's good to let it do it once and then do it again to just test. The other thing you want to pay attention to, a couple times I've planted and done that soil drainage test, and I said like, wow, that went down in like 30 seconds flat or less. And I looked on the side and there was a gopher hole in the side of the hole that I didn't realize. And so the water was just going through the gopher tunnels. And so I was like, oh my God, is this such fast drainage? But it wasn't, it was a gopher tunnel. So look around, make sure that you're not actually just digging into some cavern that some animal made and it's messing with your infiltration test. So be observant. And so you'll fill the hole with water, time it, take measurements, make measurements over time. I don't know what making measurements means exactly, but what I will say is just time it. Compare the soil type to the ribbon test result. So your ribbon test result, and then you can use the flow chart and see if they're kind of the same. Bring photos of the hole, both full and empty, as well as timing notes to the next class. So next class, and then email results and photos to wildergardens@gmail.com. So I will say just email it to me, and then I will find the kind of, like I said, I just find a sampling of people's assignments, and we'll share them and talk about them the next class. I don't know that you need to bring photos to the class itself. Just make sure that I've got the photos and some of the information, and then we can chit chat about it before the irrigation lesson, which is the next lesson. So that's the last slide. Call 811 before you dig, George says. So if you're just digging a 1 gallon pot size hole, hopefully you don't have to call 811. If it's a really big one, then yeah.
Yeah, 811, if you're digging a hole in a parkway, call 811. You have to mark the area that you want to dig with white paint, and someone will respond within 3 days to let you know whether there are any pipes, wires, or anything else there. Most pipes and wires are 18 inches below grade. 1 gallon is what, 10 inches? That's,
yeah, so
you're not digging any more than that.
Yeah, so generally, if you're doing something big and it's not in the public right of way, you won't need to call 811. If it is in the public right of way, then you would. But here's the homework slide again, if anyone needs to look at it again, but it's also in your handbook. And then my email is here at the bottom, also in the chat. Somebody Brenda posted it. So wildergardens@gmail.com. Send me your soil infiltration test results. I'm excited to see. Let me know also where you're doing it. So if it's like, hey, this is in my backyard, hey, this is at a client's yard in Sun Valley, or actually, yeah, everybody send me your geographic kind of location, because that would be interesting to see, what different areas of town have as far as different kinds of soil texture and infiltration rates.
Someone had a question earlier about, or a comment rather, about Los Angeles having mostly clay soil. I can't remember who that was. Try digging holes in different parts of the same yard and see how the soil differs from one end to the other. That's
100%. That you'll find lots of variation even in the same property. LA, I mean, LA is a basin, generally speaking, unless you're in like the foothills and such, but, LA basin and has a lot of also that kind of alluvial influence. And so you will see certain types of overall soil types, but it's also been altered a lot. So you'll see a lot of variation. And just depending on where you are, LA is also part of the Santa Monica Mountains, and that's, mountain or hillsides and such have different soils than the flatlands of LA. So we're very varied.
And I think we have a couple people here from Central and Northern California. Cool. So it's going to be different. We are at 8 o'clock. I think everyone got their questions answered in the chat. I did put Catherine's email. I put a link to a bee class that we have coming up. In the picture here, you can see a Sonoran bumblebee, beautiful, beautiful California native bee. And I also put in the chat a link to the Theodore Payne YouTube channel that has how to dig a hole. It has lots of information on fire-wise gardening, etc. So it's a good resource to have, not only for this class, but in general.